We use functions to transform the data values from the source to the target. They relate the input to the output. In the diagram on the right, you can see the input is represented as x, and that could be any range of values. The function is represented as f. That's the transformation that you're applying to x, and then the output is f applied to x. That's the output data value. And so the function defines one variable x in terms of another fx. So fx is a function of x. So if fx equals 10 and f is times 2, then x would equal 5. Or for example, if fx equals 8 and f is times 2, then x is going to equal 4 in this case. We can use this to describe mathematical functions, but also kind of how the world works. If the amount of oxygen is a function of altitude, then the higher you go, the less oxygen there's going to be. And x and fx are not just a single value. They're typically applied to a set of input values in which the function is applied and returns a set of output values. Spreadsheets are a great way to acquaint ourselves with functions. If you remember, spreadsheets are arranged into columns and rows and cells, and the cell value is represented in the function or formula bar. And so if I enter, for example, in A1, a number 1, then if I look in the function bar, I will actually see the number 1. But I can also set the value of a cell equal to the function rather than a literal value. So for example, in A2, I set the value equal to A1 plus 2. In this case, it's 1 plus 2, and so the value displayed in A2 is 3. A2 is a function of A1 plus 2. There are hundreds of functions available to you in a spreadsheet. If you click in Google Sheets, for example, and go to Insert and Function, you can see them all arranged there, including some basic statistical functions and then all these different categories of functions. We're going to focus on cell reference, text, mathematical, logical, statistical, and geospatial functions. Cell reference functions allow us to take one cell and refer to the value of a different cell or cell range. In spreadsheets, each cell is identified by a lettered column and a numbered row. So in the example on the right, you can see that the columns are lettered A, B, and C, and the rows is 1, 2, and 3. And A1 is the address for the top left cell. So we use cell reference to refer to values, and we can do it for one cell, as you see in the example on the right, in the function, which begins with an E in the function bar you see there, A1 plus 2. In this case, we're referring to one cell, A1, and then we're adding the value 2 to it to result in 3. So you can refer to one cell, but you can also refer to contiguous cells. You can refer to different cells in different areas of a worksheet or on worksheets that are in the same workbook. It's very flexible. When you copy a cell reference from one cell and paste it to another, you're either copying the relative cell reference or the absolute cell reference. The relative cell reference is updated relative to the position of the copied cell. The absolute is fixed or locked to the original cell reference, and I'll show you an example of that in just a second. So cells can be referenced by A1 notation, but also by named reference, and I'll go over that as well. In this example, we see two views of the same Google Sheet. On the left are the values as displayed in the Google Sheet, and on the right are the references. And I can see the references by going to View on the menu and clicking on Show Formulas, and it shows me the references. So in the sheet on the left, in column A, those are values 1, 3, 9, and they're also, you can see the actual literal values 1, 3, 9 in the sheet on the right. But when we get to columns B and C, we can see we're utilizing cell references. In column B, we're utilizing relative references. In column A, we're using absolute references. So if we copy the cells B1 and C1 and then paste them in B2 and 3 and C2 and 3, but we utilize relative reference for column B and absolute reference for column C, you'll see that we end up with different values. With relative reference, when we copy B1 down to B2 and then B2 to B3, it changes the reference of the cell relative to the original position. So A1 becomes A2 and A2 becomes A3. But if we use absolute reference like in column C, and we're using dollar signs to fix the location of that cell, you can see that it keeps referring to the same cell, in this case is A1. As mentioned previously, you can refer to a single cell or, for example, a range or group of cells. So the example on the right shows in A5, B5, and C5 different types of references, a ranged reference, a named reference, and a sheet cell reference. Now, if you look at the example on the left, you can see that all the values are the same, but we're referring to them differently. So in A5, we have the function equals sum, and then the range A1 to A3. And so it sums up 1 plus 3 plus 9, in which the resulting value is 13. That's a ranged reference. A named reference is where you actually name a range or a group of cells, and then you refer to that in the function. So we've utilized the name ranges panel on the right-hand side of your screen there to add a new range for sheet 1, range B1 to B3, and we've named it foobar. So then when we enter the function in the spreadsheet, instead of putting the range in there, we can just put the named range in there. So equals sum, open parentheses, foobar, close parentheses. When we hit return, we get, again, the same sum, which is 13, because it's referring to just B1 to B3. You could imagine utilizing this to represent, for example, a range of values that are expenses. And so instead of referring to the actual A1 notation range, you would just call it expenses and then refer to that in the function. The last type of cell reference there is a sheet cell reference. And so in this example, I'm not even referring to cells that are on sheet 1. You'll see at the bottom of your screen there, there's two tabs, sheet 1 and sheet 2. And so that particular cell, which is C5, is using a function that refers to A1 cell on sheet 2, which we can't even see visible on our screen. But again, we get the same value. In this case, it happens to be 13. Text functions are used to manipulate text values. We can use it to reformat, convert, concatenate, and parse and identify values. When we reformat values, for example, taking values that are either in uppercase or lowercase, or maybe it's a mix of cases, and we take all the values in the column and we use the proper function. So we say equals proper, and then we refer to some cell ranges. And when we do that, we can convert everything, for example, to title case, where the first letter is capitalized and all the rest of the letters are not. Trim is another example of a text function that we often use, in which we're trying to get rid of leading and trailing spaces. Now, leading spaces, they're pretty visible in values because your data doesn't quite line up, but sometimes you'll end up with data that have a bunch of trailing spaces on values. So you might have a value like residential or commercial or industrial, different land use types, but there are trailing spaces on there. And so then when you go to analyze the data, there's two different types, quote unquote, of residential values. There's residential values that don't have any trailing spaces, and then there's some other value that has two trailing spaces. And so it messes up your analysis. So we'll use trim to remove those spaces so they don't interfere with our analysis. Convert values is a function we use to convert values from one format or style to another. Date value is a good example. Dates often come in all different types of values. Maybe they have the year / month / day, or maybe it's month hyphen day hyphen year, for example. And we want to convert all those values to a single range so that we can utilize it, for example, to perform a temporal selection on our data. So date value will take all the different date strings and then format them into a single date value consistent across all of our data. We're often converting either our text data to numeric data or numeric data to text data. Zip code is a good example. Sometimes zip code comes across as a numeric value because it's a number, but we really want to represent it as a text value. And so we'll use, for example, the function equals to text to convert a numeric zip code field over to a text value. And of course, sometimes we go the other way. We're converting the text values over to numeric values. I mentioned previously that concatenate and parse are the types of functions we use all the time. In spreadsheets, the ampersand is what we use to concatenate cell references and or text values that are arranged in quotes. So for example, if I concatenate street name and street type into a new field called street, then I might say street ampersand, quote, space, quote, ampersand, type. And when I do that, it'll actually put the street name and then space and then the type. That's a good example of concatenate. Parse is again where we're splitting things out. Write is a type of function. Left and actually split are examples of functions that we use all the time to return a substring. In the example of write, you're taking just the values that are on the right for a specified number of digits and putting that into a new column. So an example of that might be I have a field that includes city and state, and I just want to isolate the state. So I can use write, give me the first two digits from the right, and then it'll just put the state, for example, in my new field. Identify values is a really useful text function. There are different types of identify values. Two common ones are unique and VLOOKUP. Unique allows us to get rid of duplicate records. We mentioned that that's something that we often do is deduplication when we're transforming data. You can use a function like unique to go through a defined range of values and then take the duplicate records and get rid of them. So you just get a set of unique records. VLOOKUP is another type of text function that allows us to look through a really long list of values. And when you find a specified value, get all the associated attributes with that. So for example, I might be looking through a user base that has 1,000,000 names, and I just want John Doe. And then when you find John Doe, I want the phone number, I want his email address, I want his physical address. And so I can use VLOOKUP to go through all those till I find John Doe and then find those associated attributes. Here you see an example of text functions used in Google Sheets. On the left are the values, and on the right, I've utilized the show formulas or show functions to see the underlying functions. And so we have values stored in columns A and B that represent the first and middle name of this data set. And then columns C through J, we're actually applying functions to transform the data till we get all the way to column J where we have unique values with the concatenated name Billy Bob plus the year. And so we do that by stepping through this transformation process. So in column C, we take the first step in which we concatenate the values. And so if you look in the lower right-hand spreadsheet at C2, you can see the function entered in there, which is equals A2 ampersand quote space quote ampersand B2. So what we're doing is taking the values in A2, we're putting a space at the end of that and then adding it to B2. In this case, it's Billy Bob. And you can see the results in the spreadsheet in the upper left-hand corner where we have Billy Bob, Ellie Mae, Billy Bob, Liza Jane. But you can see also that the data is not very clean. It has a lot of leading and trailing spaces, for example. So in column D, we utilize the trim function. And so we enter the function equals trim, refer to the C column, and then when you look at the results in the upper right-hand corner, you can see that it trims out all the spaces. We still have some inconsistencies in our data, including the case. So in column E, we utilize the proper function to standardize the case in which we have some upper, some lower, and some mixed case. And so the function is equals proper, open parentheses, and then in this case, it's going to be the values in column D. And you can see the results again in the upper right-hand side in column E have the standardized case. Column F is an example where we have dates that are a non-standard format. And this happens a lot, and you have to standardize the format before you can actually perform your underlying analysis. So in column G, we utilize the date value function to standardize all the date values that are in F. And if you look in the upper left-hand spreadsheet, you can see we're taking the non-standardized values in the date field and we're standardizing them in the date value field. And this is just 4 records. It'd be easy to do manually, actually. But again, if you had 1,000 or 1,000,000 records, it can be done in seconds. For our particular example, we're interested in just the year, and so we need to convert the date, which is a number, to a text value. So in column H, we use the function equals to underscore text to the values in column G. And when we do that, we convert those numeric date values in column G to column H. And if you look at column G in the upper left-hand spreadsheet again, you can see that they're aligned right. Values that are aligned right are typically numbers, and then when we convert it over to text, we can see those same values, but now they're aligned left, which means it's text. Once we've done that, now we can utilize parse, and concatenate to get our name year. So column I actually utilizes both functions, concatenate and parse, to combine the values that are in column E with the values that are in column H, but we don't want all the values. We just want the year. So that is the first 4 digits from the right. So if you look at the function in the lower right-hand corner of your spreadsheet, you can see that, for example, in I2, we enter equal E2 ampersand quote space quote, which then takes the value E2, which is going to be Billy Bob, and puts a space on the end of it. And then now we're concatenate that with the parsed value from column H, which is going to be from the right-hand side, we're going to go 4 digits, which is going to be the year, and then we're going to concatenate that to the name Billy Bob. And so when you look at the results of the name year column in the upper right-hand spreadsheet, you can see that it's combined both the name and the year. But we do have a duplicate there in Billy Bob 2020, so we utilize in column J the unique function to make sure all the values in column I in the range 2 to 5 are unique. And so then we end up with just 3 values in column J shown on the upper right-hand side of your spreadsheet. Last, I want to show you VLOOKUP. You can see that example at the very bottom of the spreadsheet. If you look in the values, you can see I'm identifying as VLOOKUP, and then the actual function is in F7. If you look in F7 in the formula spreadsheet on the lower right-hand side, you can see it has the text function EVLOOKUP, and it says for E7, in this case I've typed LMA, look through all the values in column E and column F, find LMA, and then give me the values, both LMA and the second value that's just to the right. And so in this case, that happens to be the date value. So it goes through a long list of values. In this case, it's only 4, finds LMA, and then also identifies the date for LMA, which is July 4th, 2020.